This factory never stops. Not at night, not on weekends. To produce 10,000 tons of wire rods every single day, raw materials must flow continuously. Iron ore, sinter, pellets, scrap steel, coke, and limestone arrive by rail, conveyor, and silo systems. Nothing is stored casually. Everything is measured by the hour. Sensors track chemistry, moisture, and volume in real time. Any fluctuation upstream will multiply downstream. At this scale, consistency is survival. Iron ore does not arrive uniform. It comes from different mines with different chemistry, so the first operation is blending. Multiple ore streams are crushed, screened, and mixed to stabilize iron content. Magnetic separators remove unwanted material. Fine particles are controlled carefully. Automated systems adjust ratios continuously. The goal is simple: feed the furnace material that behaves the same every minute of the day.
Keep an eye on the Fe2O3 concentration here.
Confirmed.
The automated system is adjusting the blend ratios.
Fine ore cannot go directly into a blast furnace, so it is reshaped. In sinter plants, ore fines are layered with coke fines and flux, then ignited. Heat fuses particles into porous, breathable slabs. In parallel, pelletizing lines roll ore into uniform balls and harden them in rotating kilns. Thousands of tons move through these systems every shift. The output must be strong enough to survive extreme furnace conditions without collapsing airflow. Blast furnace is the heart of the operation. Layers of sinter, pellets, coke, and limestone are charged from above. From below, superheated air blasts upward at enormous pressure. Temperatures exceed 1500 degrees Celsius. Carbon monoxide forms and strips oxygen from iron oxide. Molten iron separates and sinks. This is hot metal. Liquid iron, flowing continuously. Above it floats molten slag, carrying impurities away. Both streams are tapped separately, without interrupting production. Thousands of tons of hot metal leave the furnace every day.
We're almost at capacity on vessel 4.
Keep the flow steady, watch the temperature.
Hot metal alone is not steel. It still contains too much carbon, so it is transferred immediately to the basic oxygen furnace. A lance injects pure oxygen at extreme speed. The reaction is violent. Carbon burns off in minutes. Silicon, manganese, and phosphorus are removed. Chemical composition is adjusted precisely for wire rod grades. Each heat lasts only a short time, but the sequence never stops. Molten steel flows out, wiped clean, controlled, and ready for shaping. Steel does not cool between steps. It flows directly into continuous casting machines. Water-cooled molds solidify the outer shell. The core cools gradually as the strand moves downward. The steel is cut into billets, long square sections glowing orange. Casting speed, temperature, and withdrawal rate are synchronized. Any delay would disrupt the entire plant. Hundreds of billets are produced every hour. Some billets go straight to rolling. Others enter buffer zones to maintain flow balance. Before rolling, every billet must reach the same temperature. Reheating furnaces raise steel to 1200 degrees Celsius. Uniform heat is critical. Uneven temperature causes shape defects at high speed. Once stabilized, billets exit the furnace, ready for deformation. This is where scale becomes visible. Billets enter the rolling mill and immediately begin to stretch. Roughing stands, heavy rollers reduce the square billet, shaping it roughly round. Intermediate stands, steel accelerates rapidly. Diameter shrinks. Length multiplies. Finishing block. The final section operates at extreme speed, up to 120 kilometers per hour. The steel moves faster than the eye can track. Surface scale explodes off the rod. Diameter tolerance is measured in micrometers. One billet becomes kilometers of continuous wire rod. All rolling stands are synchronized automatically. Any mismatch would snap the steel instantly. fresh wire rod is still glowing hot. It passes into controlled cooling systems, often called Stellmore lines. Airflow, spacing, and speed regulate temperature drop precisely. This is where mechanical properties are defined. Strength, ductility, consistency. Cool too fast, and the steel becomes brittle. Cool too slow, and performance drops. At this scale, cooling is as important as rolling. The continuous rod is guided into automated coilers. Large loops form rapidly. Each coil weighs 1 to 2.5 tons. Hundreds of coils are produced every hour. Pattern and tension must remain perfect. Any overlap or twist creates defects. This is wire rod at industrial volume. Inspection never stops. Laser gauges monitor diameter online. Cameras scan surface defects. Samples are pulled for tensile testing. Any deviation triggers immediate correction. Coils that fail are diverted and recycled. Nothing leaves the plant unchecked. At 10,000 tons per day, error margins are unforgiving.
Positioning is good there. Secure the load and proceed to Station 3.
Approved coils are labeled, tracked, and staged. They move out by rail and truck continuously. Each day, total output reaches approximately 10,000 tons of wire rod. Grades vary by customer, but the flow never changes. Steel in motion without pause. Every minute, steel moves forward. Every hour, hundreds of coils form. Every day, 10,000 tons leave this factory. A single uninterrupted chain from iron ore to high-speed wire rod. This is industrial steelmaking at full scale.